and then it's pushed in a queue ordered by score. And by the way, all the nodes that are on the same score are popped off, like those guys who have the same score obviously are popped off first, right? And then what's happened is they're chosen in a round robin fashion, right? And then returned as the node. Because by the way, it's not doing it randomly, because it's just making sure that it chooses different nodes, right? It's intentionally doing that. Oh, actually, it says that. I didn't even know that. It doesn't do random choice to just make sure that there's an even distribution of stuff, right? Okay, that's it. It's just that simple. Can you run me? Who's the best? That's it. Two-phase approach. If you even go and look at the Kubernetes documentation, which I think they actually use different names. I can't remember the name of it. They have used different names, if I remember correctly. Filtering and scoring. That's right. I remember. Identifying who can is called filtering. Scoring them to see who's the best, it's just another name, right, for like node selection by the scheduler. That's all it is. So sometimes you see predicates and priority. Sometimes you see filtering and scoring. Just depends on whose documentation you're reading, right? That also makes sense, right? Because that, like, who's the best is just a scoring step. You're just doing comparison at that point. Okay. Now, what happens if the scheduler is like, man, node 15 is the best. It's got free memory. It's got 4 free processors and 8 gigs of RAM. It's the best for this thing. And so it goes and tells the kubelet to schedule. And then when it gets pulled down, like it's pulling down the image to run it, all of a sudden it doesn't have the resources. Node 15 does not have 4 free processors and does not have 8 gigs of memory. And so since that's a hard limit that it must have, and it doesn't all of a sudden have it because all of a sudden 5 other pods came in, then what happens is that it drops the deployment, the pod, it drops the request, and it goes back and tells the etcd system, it says, hey, I can't take this. I'm not scheduling this. The scheduler sees that it's unassigned because the node's been removed from the node name for the pod, and then the scheduler goes back through and does the process again, right? So just know that if it goes to deploy and someone eats the resources before it gets there, it drops it and schedules it again. It happens really fast too. So yeah, and the pod's marked as failed. So that pod name that it creates literally gets dropped and it creates a whole new pod name. So that's what happens. And that's really the only contention that can happen, is that the predicate is violated. Now, what if you go to schedule something on node 15, but it had 20 gigs free, but now it only has 10 gigs free, but I only need 8. If the prioritization gets violated, that doesn't matter, as long as the predicate still runs. In other words, if I need 4 CPUs and 8 gigs of RAM, and this was my favorite system because it had 20 gigs free, but it dropped to 12 gigs free instead, that doesn't matter. The kubelet can still actually run the pod, so it's still actually going to schedule it. So just because it's no longer your favorite box, but it still meets the minimums, it's going to schedule it. So don't worry if you're like, it's no longer the best. It's not going to go back through the scheduling process. The only time it's going to go back through the scheduling process is if it fails the predicate. You cannot run my pod anymore. That's the only time it's going to go back through the scheduling process. Yeah, I think that covers that pretty clearly, actually. All right, so then how do we control scheduling? Because I just told you that I talked to a bunch of Kubernetes captains and asked them the question. They're like, we don't ever really mess with the scheduler, which I'm sure is not true. I think they're actually messing with the scheduler. So then how do you control that otherwise, right? Well, what you do is you put labels on things. That's what you do. And we have a lab for this that you're going to do tomorrow morning to confirm this. But we've talked about this, right? What if you want to do machine learning? What if you want to label it as a bad actor? You put labels on the nodes, and then you put that in your pod specification. The node has a label, and you tell the pod to go, if the label equals Windows, if OS equals Windows, you can go here. Otherwise, if OS doesn't equal Windows, you're not going to use it, right? So label selectors will allow you to label nodes, a group of nodes, and set your pod specification to only use those labeled nodes. Here should be a good example of this, or a decent example. where let's say we come in and we label Minikube where OS equals Linux, right? Which is already done, by the way, so we don't have to do that. And we come in here and we add a node selector section underneath containers, right? That says, I want the OS equal to Windows as an example. Let's say it's Windows. If I got 30 systems where the OS, the label on the system says OS equal Windows, I can run on any of those 30 systems. It's really pretty straightforward. But remember that when you do something like this and you set up node selector, does this use scheduling or does this bypass scheduling?
It'll still use scheduling because it has to choose one of the 30, right?
That's right. That's exactly right. If you set a node name in here, it's going to go straight to the node, right? If you set a label in here that has a group of systems associated with it, then it's actually going to go back to the scheduling process because it's still got to figure out of those who it's going to use, right? Now, labels is one way to control things. You can also use what's called affinity or anti-affinity. Here's the difference, right? Affinity can represent more complex structures in terms of like logical operators than labels can, right? So for example, here's the example where a pod's going to schedule onto a node with a label one with either this value or this value, right? When you set the spec inside the pod, you can actually set affinity and you can set a particular node affinity. And by the way, I got to tell you, these effects really crack me up because you can have required during scheduling and ignored during execution. This is what this means. In short, meaning that it will stay on this node once it gets scheduled there, even if something changes about the labels of the node. That's what ignored during execution means. Meaning if this is your favorite set of boxes and you schedule a pod to come out here because the affinity says, hey, this is either A or B, and you schedule it onto the node, and then later on, these are no longer your favorite boxes, and you take label A and B off of these boxes, it's not going to evacuate the pod because it says ignored during execution. Meaning once it's already there and executed, if you change the labels or lose the labels or someone accidentally deletes the labels, which is what happens, by the way, then this thing isn't going to dump all its pods that don't meet the affinity standard. Just something to be aware of, because with labels, if you dump the label, there's no option to keep this thing running if someone messes with the label. With affinity, you can actually make it so that if the label accidentally goes away, the node's not going to dump all the pods, right, that don't match, or the pod itself isn't going to evacuate, right? So there's a lot more complex matching expressions that you can do with affinity that you cannot do with labels, even though it uses labels. So don't get me wrong, it does use labels, but affinity in the pod specification has more matching terms, more matching possibilities. It also, by the way, has anti-affinity, where you can say, look, I don't want you to match. Stay away from these guys, right? These are my machine learning systems. Stay away from them unless I tell you otherwise, right? Because those have GPUs on them, and I don't want you to use them because they're specialized for machine learning. So unless I tell you to go there, you can use any other box you want to, but you can't use these because those are my machine learning boxes, right? So you can use affinity and anti-affinity to basically create decision-making processes for how the scheduler chooses one set of boxes over another. That's what affinity and anti-affinity do. They allow you to attract pods to a box or repulse pods from a box or set of boxes. Labels can really only attract, although you can put negatives in there. Now, the third way, other than labels and then affinity and anti-affinity to control scheduling, is through taints and tolerations. So what's interesting about taints and tolerations is that the other things were really where you're just labeling nodes and then you're going in and setting pod specifications. You're setting affinity and label, like node selection, inside the pod specification. Here's the funny thing about taints. Taints are interesting because taints are node only. By the way, that's an awesome dog, Jonah. Taints are node only. So you see this where you're tainting a node. Yes, I used to giggle like a 12-year-old every time I used to say that. So when you taint a node, by the way, there's the key, there's the value, and then there's the effect, right? So notice the effects there. I can actually go out and go to Minikube right now, taint this box to no schedule, and it will no execute, and it will evacuate all the pods off the system except for the system pods. Because that's what no execute does. No execute says, get out. No one's allowed to run here unless you have the matching toleration. So you might say, well, Michael, why would you do this? Why would you go to a box and say, everybody get out? Or, hey, no one else can be scheduled on this box. Why would you do that? Forensics. I've had nodes. You'll love this story. I had someone take a Rancher Kubernetes cluster and stick it on the internet. And I told them specifically, do not stick this box on the internet. Rancher has a bunch of CVEs on it. By the way, this was like 4 years ago. They all got fixed. I said, Rancher's got a bunch of CVEs on it. If you do this, we are going to get into crypto. I literally said that to my guys. I was the vice president of operations. I said, literally, if you do this, we are going to be getting into the crypto business because they're going to compromise us and they're going to run a bunch of Bitcoin miners. And I literally said that to my guys. And one of them made a mistake and it was totally fine. There was no like repercussions on it. But immediately that box was out there for 10 minutes. Immediately someone hacked the box, figured out all of our capacity, evacuated all of our pods to a certain set of nodes, and then ran a bunch of crypto miners. And that all happened within like 3 minutes. So, security, we alerted security right away, which means don't touch anything, freeze everything in place and lock it down as much as possible, but don't let it go because they need evidence, right? You can't go in there and just start deleting stuff in order, and there was no violation of service because we weren't using the cluster for anything. It was just a test, right? So immediately we actually set it to no schedule, which means everything that was there stayed there, right? And then we added in the pod specifications that said you have to stay on this node, because I don't want anything that's there moving to any other node. I don't need more compromises, right? So I said, stay there and nobody else can schedule on the system, on these particular systems. And so what happened is that we tainted the node for no schedule. And then we basically changed the pod specifications for the pods that were there and say, I want you to keep you there, right? Now, what's interesting is that, we ran tools and security came in and do their thing and we snapshotted it and we took images and blah, 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 blah. And so I remember the security guy standing next to me and he goes, well, what do you want to do now? I was like, well, I want you to find this guy and I want you to hire him because he might be the best DevOps engineer I've ever seen. Because whatever he just wrote, he just maximized capacity and wrote a Bitcoin miner in like 5 minutes. I would love to have this guy on my team, right? Turned out that he was hiding under, some GitHub account, whatever. We never found him, right? Which is totally fine. It's hard. But just know that in order to get to the security tools onto that node after we had tainted it, we had to do this. We had to create a toleration. So in the pod, we had to go in and say something like this. So this is what we did, is that we tainted the node. We actually did no schedule. We didn't do no execute. And what happened is that in the pod specification, we had to come in and say, hey, by the way, it's okay for you to go onto this node. As a matter of fact, we put in the pod specification, not only is it okay, we want you to go over here. Don't go anywhere else, right? And then what happened is that allowed us to run the forensics tools on the system because they're in an immutable pod, right? They're in an immutable container. And so we just went in there, logged in there, got all the information, snapshotted, did some troubleshooting, gathered all the logs and information we could, and then we were out, right? But the taint prevented anybody else from coming onto that system. And so, but in order for us to get the security tools there, we had to put a toleration into the pod specification for the security tools to allow it to come on. Once a node is tainted, you cannot allow any pod onto that node unless it has the exact toleration for the taint. In other words, if I, notice in this particular example, that's literally on the page here, there are 3 taints on this system: key 1, value 1, key 1, value 1, and there's no schedule, no execute, both key 1, value 1. And then the third one is key 2, value 2, no schedule, which is actually a duplicate of 1, except the keys are different. The keys and values are different. If you don't have all three of those tolerations on your pod specification, which in this case they do not, you won't get onto that node. They have to match exactly. Notice that they have key one they have key one value one. They have key one value one again, because they have it for both the no execute effect and the no schedule effect, but they don't have this. So that pod's not going to run on that system. Even if you tell it to put it on that system, it won't, because it doesn't have the third toleration necessary to make that happen. Make sense to everybody? Any questions, confusion around taints and tolerations at least? When you cordon off a node with Kubernetes, you're basically tainting it. You're saying, don't run anything on this thing. I'm draining it. I want you to coordinate, drain everything off of it. We're done.
Taints and tolerations are kind of like a yellow police line.
Yellow if you say no schedule. It's a blockade if you say no execute. Get out. You're done. Right? That's what no execute is. Get out. You're done.
Cool.
Nobody can be here anymore.
It sounds like you could maybe use alternate words, bans and exceptions, to describe taints and tolerations.
I think that's accurate, right? It's like you're banned unless you have an exception to get in, right? Okay, so ignoring the node name selector, right? You can put labels, you can do affinity and anti-affinity. You can, oh, wow, look, my timing's good. You can actually do taints and tolerations, right? Those are the three ways you can control the scheduler outside of modifying the scheduler directly, which again, I confirmed, nobody does that. So I'm sure somebody out there does, right? So that's it. So just remember, the scheduler runs on the leader. Its job is to simply like figure out which nodes are which nodes are the best, right? And that's it. And then once it figures it out, it actually puts it into etcd and says, hey, I'm going to tell this node to go do it. And then the kubelet like is told, hey, go run this pod. The kubelet runs it. And once it's successful, it goes back and says, hey, I'm actually running this thing. I'm good, right? I got it. If you want to control that, you can use labels to control it. Obviously, you can use node selector as a specific label to do that. You can also control it through affinity and anti-affinity. You can also use taints and tolerations. One word of caution. I don't know if you noticed this, but this is one of those things that has the minus sign at the end in order to remove a taint, right? Just know it's got that funky little minus sign at the end if you want to remove it. That's how you don't delete it for whatever reason. You just put a minus sign on the end. This patching, by the way, if you patch the specification for a node, you can actually remove all taints and tolerations just by putting those empty brackets in the specification for the node. So that's actually a pretty good command to remember.
You said you can or you can't?
You can. So if you've got 15, like, you know, and I've seen this before, if you've got like 15 taints on a node and you need to clear them all out, just go ahead and run this patch command and it will literally clear out all of the taints on the system. Yeah, that was a, Mark, that was a junior sysadmin kind of, yeah, figuring it out.
I feel like that was a missed opportunity to use the word exercise. Exercise all the taints.
Yeah. Like I said, it took me a while to not giggle like a 12-year-old when I first started teaching this class. So
I couldn't help it either. I'm sorry. I was dying over here.
That's okay. It's all right. There's just been so many jokes using that word. So, you know, moving on. All right. So that being said, we accomplished what we needed to accomplish today. We're going to open tomorrow at 8:30 straight into lab 9. So we have a taints and tolerations lab. We have a scheduling lab, right? That we're going to walk right into. It's only got 3 parts. They are little dense parts, but they're not hard. So that's what we're going to roll into tomorrow at 8:30. So when I see you in the morning, that's where we're going. Before we close, does anyone have any questions or anything burning before we stop?
Do you suspect we will actually finish the other, was it 4, 5, 6 chapters tomorrow?
Absolutely. Yeah. So we have four, we basically have 5 labs to do tomorrow. And we have the remaining chapters. The rest of these go really fast. Networking is the only one that kind of like can take a minute, but we'll be done with that before lunch. Most of the
You
day
have it.
tomorrow, by the way, will be spent with labs, just FYI.
Do you have any recommendations for reinforcing knowledge through Udemy or Pluralsight, or if you ever use those courses or anything like that?
I'm a big fan of Udemy, actually. Like I find stuff on there all the time. That's awesome, especially some of the Docker and Kubernetes captains publish stuff out there. But if you want, I can give you a list of recommended resources, because I usually send you a list of a bunch of training items that you can do after this. So you'll get that on the last day. I just like to overwhelm people on the first day
And
or second day.
I have not actually looked yet, but I think we do have Udemy stuff for booze, free
You have
classes, right? So,
You have Udemy for business. Yeah.
okay.
Yep, it's my favorite thing ever outside of
Nice.
Pluralsight. Both
Yeah.
of those, I'm on it almost every night.
Wow.
Awesome. Good deal. All right. Yeah. So don't worry. Several people requested. I'll make sure it's included in that last email. So you get a bunch of stuff from me. Cool. All right, everyone. Well, have a great night. Hold on. Wait, hold on. Scott. Okay. Hold on. I gotta tell you this. I actually arrogantly walked in like 2017 or something to take the DCA thinking I was just going to ace that thing. And it slapped me in the face like a pimp. I failed that thing so horribly. And then I was like, oh, and then I got the CKA and I thought I should go back and actually do that. Right. I'll be frank, unless you're a
Money got
developer,
away.
if you're a developer, most people don't care about Docker certified associate.
Yeah.
If you're on the infrastructure side of things, they care about Kubernetes. Yeah.
Okay. I figured it'd be
I
good.
think I have a feeling Jonah goes to the gym, by the way, Brian. So that's funny. Anyway, what you were saying, Scott.
I know they had a course on Udemy about it. I figured it'd be good information, but I don't know if I did the DCA.
I think if you wanted to pick and choose what was an interest for you for Docker, I think that would make sense, especially if you're trying to accomplish a task. I wouldn't go for the DCA. Honestly,
Yeah.
Docker is falling out of favor a little bit. So yeah.
I keep
right.
hearing that. I keep hearing that Docker is going away
it's so
throughout the
convenient.
DoD. I've heard of like Podman is coming up or something like that.
I mean, it's just gonna shrink. Like right now, it's like the de facto, but it's like Coca-Cola. When Pepsi came along, and then you got like, what would someone say to me the other day? Shasta. I was like, Shasta? Who drinks? I don't even know if Shasta's still around. Regardless, there's so many choices in like colas nowadays. If you're into that world, that's what's going to happen. Is just going to see a dilution where Docker's going to get smaller in market share. So that's all. Especially if they keep charging people for their stuff. So yeah. All right. Well, we'll see you guys tomorrow at 8:30. Be prepared to do a lab. Otherwise, we're going to be in labs pretty much all day long. So we'll see you then.
All right.
All right, everyone.
See you guys.
Have
Have
a
a
good
good night.
night.